Hello students, in this video we will be seeing solutions for previous year NEET physics question papers. So we will try to solve some of the important questions which has been repeatedly asked in most of the NEET examinations. So before going into that, I'll just give you some of the examples by which you can memorize the formula, because when you're solving a NEET question paper, the problem is time management. We'll not be having enough time to do the calculation works, and we don't even remember the formulas. So some of the physics concepts can be remembered with the help of this mnemonics. Here I'm going to show you some of the famous mnemonics which are being used to explain several concepts, but as we go, when I'm making a lot of videos, I'll try to introduce still more mnemonics which will be really useful for you to remember or memorize the formula in an easy way. So the first one is work, which is one of the famous mnemonics. W is equal to MAD. So you know, if you're doing a lot of work, you'll be having a lot of stress and you'll really becoming mad because of the overwork or overload of the work. So here if you see, W is equal to MAD, where MA stands for mass into acceleration. So M stands for mass and A stands for acceleration, so which is equivalent to force. So you know, W equal to F into D and F is equal to MA. So here we are taking it as MA into D. D is the distance, so mass into acceleration into distance. So in order to remember this, you can think of the concept like work. When you're doing work, a lot of work, what happens is you will become really mad because of the stress. So W equal to MAD, where M stands for mass, A stands for acceleration and D stands for distance. And the next one is your Ohm's law. So with the help of this small diagram, you can easily understand the concept of Ohm's law. You know, P is equal to IR. So here you can see this part is equivalent to this part, or you can take it as V by I is equal to R. So you know, V by I is equal to R. Similarly, V by R is equal to I. So you can take this part also, V by R is equal to I. So with this small diagram, you can easily remember the Ohm's law. Just, it's a very simple diagram. You're going to draw a circle. You're going to put like this, V I R, or you can think of the rhyme VAR, VAR. Okay, so with that you will be able to remember the formula in a easier way. And the next one is your SI prefixes. So you know, it starts from XA and it ends at ATO. Okay, so you can easily understand, for like every player that gets mad may never play football again. Okay, so here this, for this, every E stands for XA, and P stands for peta, T stands for tera, and G stands for giga, and M stands for mega, and this MA stands for micro, and N stands for nano, P stands for pico, and F stands for femto, and A stands for atto. So you know the multiplicity order also. Xa is 10 power 18 and your atto is 10 power minus 18. Okay, so with this statement you can easily understand, every player that gets mad may never play football again. So if you remember the statement, you will usually know the first letter stands for the prefix of the SI units. And the next one is the relationship between current and voltage in a capacitors and the inductors. So you can remember this word called civil. Okay, so civil stands for C. Okay, in capacitors, voltage, current leads voltage. Okay, so that's why I is before, whereas in inductors what happens is voltage will lead current. Okay, so if you remember this civil, you can easily understand that in capacitors current will be leading voltage, whereas in inductors voltage will be leading the current. Okay, so that's why in the reverse way you can understand. So C is front, so it is in capacitors where I is in the first, so current is leading the voltage, whereas in the case of inductors, in inductors if you see, voltage is leading current. So this word civil will be enough for you to give you the relationship of voltage and current in a conductor or in a capacitor. Okay. So the next one is the resistor color codes. So most of the questions from electronics side will be coming from the resistors. They'll be giving you the resistor value and they'll be asking you to find the color codes. So this small statement is enough for you to remember the color codes. B.B. Roy of Great Britain has a very good wife wearing gold and silver. So here this B stands for black, another B stands for brown, and R stands for red, O stands for orange, and Y stands for yellow, and G stands for green, and B stands for blue, and again this V stands for violet, and G stands for gray, and W stands for white, wearing gold and silver. So the order, the digit order. Black is having 0, and brown is 1, red is 2, orange is 3. So you can easily remember, if you remember the statement, B.B. Roy of Great Britain has a very good wife wearing gold and silver. You can easily write down the color codes and you can easily write down the digit values also from 0 to 9. So with this you will be able to easily solve the questions which is related with the resistance color codes. And to remember the electromagnetic spectrum, it is containing all the lights of several wavelengths. Here you can see the highest wavelength is radio waves. So we are going it from the highest to the lowest. So if you see radio, micro, infrared, visible, ultraviolet, X-ray and gamma. So this statement will be enough for you to remember the electromagnetic spectrum. The order, you will not forget the order, because sometimes you will be having a confusion whether after X-rays visible light comes or ultraviolet comes, or after ultraviolet visible comes or infrared comes. Like that you will be having some multiple confusions because of the order. So in order to remember this order, if you remember this statement, you can easily write down the order. Like Roman men invented very unusual X-ray guns. Okay, so here for Roman, R stands for radio, and M stands for microwave, and I stands for infrared, and V stands for visible, U stands for ultraviolet, X stands for X-ray, and G stands for gamma ray. So if you just remember this, you can easily write down the order of electromagnetic spectrum. So as you know, E equal to hc by lambda, this is the general formula, and as you increase the wavelength, the energy starts decreasing because this is inversely proportional. That's why your gamma ray is having a higher energy when compared with your radio waves. Okay, so if you see here, the radio waves, the wavelength is really high, whereas in gamma rays the wavelength is really less when compared with the radio waves. So if you remember this statement, Roman men invented very unusual X-ray guns, you can easily write down the order of the electromagnetic spectrum. Okay, so still some more mnemonics is there which we'll be discussing in the coming videos. Now we'll try to solve the previous year question papers. We'll go on with the first question. So the first question is, a short electric dipole has a dipole moment of 16 into 10 power minus 9 centimeters. The electric potential due to the dipole at a point at a distance of 0.6 meters from the center of the dipole is situated on a line making an angle of 60 degrees with the dipole axis. So here they want us to find out the electric potential. The general formula for finding out the electric potential is V is equal to Kp cos theta divided by R square. Okay, so here they have given you the K value, which is equal to 1 by 4 pi epsilon naught, which is equivalent to 9 into 10 power 9 Newton meter square per Coulomb square. Okay, and they have also given you the P value, which is equivalent to 16 into 10 power minus 9 Coulomb meters. Okay, so this is the dipole moment, and they have also given you the R value, which is equivalent to 0.6 meters, and the angle theta is 60 degrees. Okay, now we are going to substitute it in the formula. V is equal to K is 9 into 10 power 9 into P is 16 into 10 power minus 9 and cos 60 degree divided by 0.6 the whole square. So on solving this, you will be getting the potential value is 200 volt. Okay, so the correct answer is option 3, 200 ohms. Okay, so now we'll move on with the next question. A series LCR circuit is connected to an AC voltage source. When L is removed from the circuit, the phase difference between the current and voltage is pi by 3. If instead of C is removed from the circuit, the phase difference is again pi by 3 between current and voltage. The power factor of the circuit is. So they want us to calculate the power factor of the LCR circuit under two conditions. First condition is they are removing the inductor, so L is removed from the circuit, it becomes RC circuit. And the second condition is they are removing the C, so again it will become an RL circuit. So when they are doing in these two conditions, what happens is the phase difference seems to be same. Okay, so what happens here is when first condition is you are removing L, so L removed, circuit becomes RC circuit. Okay, so in this state, you know, the tan pi value will become, the phase difference is pi by 3, so tan pi by 3 is equal to XC by R. Okay, so XC will become root 3 by root 3R. Okay, now you are trying to remove the C, so second condition, C is removed, so your circuit becomes a RL circuit. Okay, so now the same conditions, tan pi is equal to tan pi by 3, which is equivalent to XL by R. Tan pi by 3, which is equivalent to XL by R. So your XL will become again root 3 R. Okay, so the impedance of the circuit is given by, Z equal to root of R square plus XL minus XC the whole square. So since both XL and XC are equal, you will be getting it as R, and the power factor cos pi is given by the ratio of R and Z. So that will become R by R, so it will become 1. So the correct answer is option 2, 1. Okay, so when you are removing the inductor, the circuit becomes an RC circuit, and when you are removing the capacitor, it becomes an RL circuit. And since both the phase difference are equal, so XL and XC will be having the same value, and you will be calculating the impedance with the help of this formula, and you will be getting the value of impedance as Z, and the power factor will become 1. So it's a very simple mere substitution of the formulas. Okay, so next we'll move on with the third question. Light of frequency 1.5 times the threshold frequency W incident on a photosensitive material. What will be the photoelectric current if the frequency is halved and the intensity is doubled? Okay, so here there is no much calculations in it, it's just a mere theory. Here what they have told is, they have said that light of frequency 1.5 times the threshold frequency W is incident on a photosensitive material. So as when the frequency of the incident light is halved to its original value, that is 1.5 V0, then it becomes less than the threshold value. Okay, so when you are trying to reduce the incident light frequency, automatically its value will become less than the threshold value. So when the incident light and frequency is less than the threshold frequency, then automatically no photoelectric effect will be taking place. So no photoelectrons would be emitted, and the photoelectric current will become 0. Okay, because the incident light frequency is lesser than the threshold frequency, so there will not be any photoelectric effect taking place, so the number of photoelectrons emitted will be 0. So the correct option is option 2. Okay, so now let's move on with the next question. Question number 4. The capacitance of a parallel plate capacitor with air as medium is 6 microfarad. With the introduction of dielectric medium, the capacitance becomes 30 microfarad. The permittivity of the medium is, so they want us to find out the permittivity of the medium, and they have given us the permittivity of free space as 8.85 into 10 power minus 12. It's a constant value. So the capacitor of air capacitor is given by the formula C naught equal to epsilon naught A by D. So this value they have given it as 6 microfarad. Okay, so when the dielectric of permittivity epsilon naught R and dielectric constant K is introduced between the plates, then the capacitance will become C equal to K epsilon naught A by D. So this value they have given it as 30 microfarad. Okay, so now if you take the ratio of C by C naught, you will be getting the permittivity of the medium. So it is C by C naught. If you put, it will become K epsilon naught A by D into D by epsilon naught A. Okay, so this will get cancelled, this will get cancelled. So you will be getting it as 30 by 6. So your constant value will become K is equal to 5. Okay, so the permittivity of the medium is given by epsilon r is equal to dielectric constant into permittivity of free space. So this will become 5 into 8.85 into 10 power minus 12. So the value will be 0.44 into 10 power minus 10 coulomb square Newton inverse meter inverse square. Okay, so the correct option is option 1, 0.44 into 10 power minus 10. Okay, so the next question is, an electron is accelerated through a potential difference of 10,000 volt. Its de Broglie wavelength is nearly. So they want us to calculate the de Broglie wavelength of an electron which is accelerated through a potential difference of 10,000 volt. So it's a very simple problem. You have to just substitute in this formula. Lambda is equal to 12.27 divided by root of V. Okay, so here they have given you the voltage as 10,000 volt. Okay, so you are going to substitute it. So this will become 12.27 into 10 power minus 10 divided by root of 10,000. So if you solve this, you will be getting the value as 12.27 into 10 power minus 12 meter. Okay, so the correct answer is option 4, 12.2 into 10 power minus 12 meter. Okay, now we'll move on with the next question. Average velocity of a particle executing simple harmonic motion in one complete vibration is. So here, you know, if you just consider a pendulum also, it will be having a motion like this. It goes in this direction and again it comes back, and it goes in this direction and again it comes back to its original position. We call this as one oscillation. Okay, so it moves in one direction towards the left hand side and comes back to its mean position. Again it goes to the right hand side, and when it is coming back, we call it as a single oscillation. So simple harmonic motion is a special type of periodic motion where the restoring force of a moving object is directly proportional and opposite to the object's displacement vector. Okay, so it will be directly proportional to the displacement vector. So in one complete vibration, what happens is the displacement becomes 0. So the displacement is 0. So what happens to the average velocity is that will also become 0, because the average velocity is given by displacement by time interval. Okay, so here what happens is, since the displacement is 0, your average velocity also will become 0. Okay, so the correct answer is option 2. The average velocity of a particle executing simple harmonic motion is 0 for a complete vibration. Okay, so now we will move on with the next question. Increase in temperature of a gas filled with container would lead to. So what happens when you are increasing the temperature? That is, you are having a container filled with gas and you are going to increase the temperature of the gas inside the container. So you are going to heat the container, for example. So what happens is, on increasing the temperature, it will lead to the increase in kinetic energy. Okay, so because when you are heating a container which is containing gas, the gas molecule starts to vibrate, it starts to absorb the energy and it starts to have a kind of a motion, it starts to vibrate. And because of the collision of the gas molecules, what happens is the pressure inside the vessel increases. So this option is wrong. They have given it as decrease, which is wrong. And again, the intermolecular distance will start moving out. Okay, so it will not decrease, so that is also wrong. And the mass will not be affected by the temperature. The mass is not going to be affecting the gas molecules. So again, the mass increase in mass is wrong. So the only option is increase in its kinetic energy. So on heating a material or a gas container, what happens is its kinetic energy starts increasing. So the correct option is option 4, increase in its kinetic energy. So these are all like small questions. Just as you read the question itself, you will understand. Within some 5 to 10 seconds you can easily solve it and you can move on with the next question. Okay, so the next question is, when a block of mass m is suspended by a long wire of length L, the length of the wire becomes L plus L. So the elastic potential energy stored in the extended wire is, so they want us to find out the elastic potential energy stored in the wire. So initially the length of the wire, so you take a thin wire like this. Okay, so initially the length is L, but what happens when you are adding a mass, the length gets elongated. Okay, so it gets elongated and it becomes L plus L. So this is the elongation. Okay, elongation. So they want us to calculate the energy stored. So here you are applying a force, the mass, you are adding a mass which acts as a force, it's kind of a stress, and there is a deformation in the wire length, so which is called as strain. So first thing is, you have to calculate the stress and you have to calculate the strain. So the stress is force per unit area. So here the force is mg, force is acting in this direction. Okay, and the strain is given by elongation per unit length. Okay, so here the elongation is small l and the length of the wire is capital L. Okay, so you have now calculated the stress and strain. The energy per unit volume is given by, the energy per unit volume is given by half into stress into strain. Okay, so here the volume is given by the area of the wire into its length. So it will become A into L, the length of the wire into the area of the wire. So this will become E by V is E by A into L into half into, what is the stress value? Stress is mg by A and strain is L by L. So this A and L will get cancelled. So you'll be getting it as half mg. So the correct option is option number 1, half mg L. Okay, so now we'll move on with the next question. The fundamental frequency in an open organ pipe is equal to the third harmonic of a closed organ pipe. If the length of the closed organ pipe is 20 centimeters, the length of the organ pipe is, so they want us to calculate the length of the organ pipe. So the general equation for finding out the fundamental frequency for an open organ pipe is given by V by 2L. Okay, so by V by 2L. And the frequency of the third harmonic for closed organ pipe is given by, this is for third harmonic, so this is given by 3V by 4L1. Okay, so they have said that both are equivalent here, that is the third harmonic of closed organ pipe is equivalent to the fundamental frequency of the organic pipe. So you will be equating both the things. V by 2L is equal to 3V by 4L. So here you want to find out the L value, so these will get cancelled, and you'll be having it as L is equal to 2 will get cancelled, so L2 L1 by 3, and L1 is how much they given, it's 20, so it will be 40 by 3, so this will become 13.2 centimeters. So the correct option is option 3, 13.2 centimeters. Okay, so we'll move on with the next question. A carbon resistor of 47 plus or minus 4.7 kilo ohm is to be marked with rings of different colors for its identification. The color code sequence will be. So you all know, as I said in the initial slides, that you can remember the color codes with the help of mnemonics. Okay, so similarly here, what they have given is, they have told you it is 47 plus or minus 4.7 into 10 power 3 ohms. So if you see the color code for 4, it is yellow, the first digit. Okay, and 7, so if you see 7 is violet, the second digit. And if you see the tolerance factor, it is 4.7. 4.7 means it is around 10 percentage. Okay, so 10 percentage means then it is silver, so it will become silver. And the next one is the multiple of 10k. Okay, it's 1k, so it will become orange. Okay, so if you see, the correct answer is yellow, violet, orange and silver. Okay, so the color code sequence for the given carbon resistor, which is having a value of 47 plus or minus 4.7 kilo ohm, is yellow, violet, orange and silver. We'll move on with the next question. A set of n equal resistors of value R each are connected in series to a battery of EMF E and internal resistance R. The current drawn is I. Now the n resistors are connected in parallel to the same battery. Then the current drawn from the battery becomes 10I. What is the value of n? Okay, so when connected in series, what happens to I is E by R plus NR. Okay, so when it is connected in parallel, you will be having it as 10I. Okay, so this is in parallel. 10I is equal to E by R by N plus R. So which is equivalent to NE by R plus NR. So it will become 10I is equal to, this is your I value. Okay, so NI, so N will become 10. So the correct option is option 3, 10. So the N value is 10. Okay, so the next question is, an inductor 20 mH has capacitor 100 microfarad and a resistor of 50 ohms are connected in series across the source of EMF. V is equal to 10 sin 314t. The power loss in the circuit is. So here they have given you the inductor value as 200 and the capacitor value is 100 microfarad and the resistor value is 50 ohms. Okay, so they have given you the EMF value as 10 sin 314t. Okay, so you know from this equation your omega is 314, this one, and your V naught is 10. V naught is 10. So XL is given by W into L, so which is equivalent to omega, that is omega into L, 314 into 20 into 10 power minus 3. So if you solve this, you'll be getting the XL value as 6.28 ohms. Okay, so similarly capacitance Xc is 1 by omega C, which is equivalent to 1 by 314 into 100 micro. So this will become 31.8 ohm. So you know the impedance formula, Z is equal to root of R square plus Xc minus XL the whole square. Okay, so if you substitute the value of R, you know the value of R is 50 ohms and Xc value is 31.8 and XL value is 6.28 ohms. If you substitute in this formula, you will be getting the impedance value as 56.1. The power loss P is given by V naught square R by 2 Z square. So if you substitute the values, you know the value of V naught is 10, R value is 50 and Z value is 56.1. If you substitute, you will be getting the value as 0.7 watt. Okay, so the correct option is option 3, 0.7 watt. Okay, so now we'll move on with the next question. A potentiometer is an accurate and versatile device to make electrical measurements of EMF because the method involves. So you know it's a potentiometer works on the principle of Wheatstone bridge. So potentiometer is an accurate and versatile device to make electrical measurements of EMFs because the method involves a condition of no current flow through the galvanometer. So the current will not be flowing through the galvanometer. The device can be used to measure the potential difference, the internal resistance of the cell, and compare the EMF of two different sources. So the correct option is a condition of no current flow through the galvanometer. So it works on the principle of Wheatstone bridge. So no current will be flowing through the galvanometer. It is mainly used for determining the measure the potential difference, the internal resistance of a cell, and compare the EMF of two different sources. So the correct option is a condition of no current flow through the galvanometer. Okay, so now let us move on with the next question. A gas mixture consists of 2 moles of oxygen and 4 moles of argon at temperature T. Neglecting all the vibration modes, the total internal energy of the system is. So they want us to calculate the total energy of the system, and here they have given you the moles of oxygen and how much moles of argon is. The internal energy of 2 moles of oxygen is given by U2 is equal to mu into 5 by 2 RT. Okay, so here they have said 2 moles, so mu will be 2 into 5 by 2 RT, which is equivalent to 5 RT. Okay, now the internal energy of 4 moles of argon. Okay, so U argon is mu 3 by 2 RT. So here it will become 4 into 3 by 2 RT, which is equivalent to 6 RT. Okay, so the total energy will become total internal energy. So the total energy will become U is equal to U oxygen plus U argon. Okay, so this is all. So this will become 5 RT plus 6 RT, which is equivalent to 11 RT. So the correct answer is option 411 RT. Okay, the next question is a Carnot engine having an efficiency of 1 by 10 as a heat engine is used as a refrigerator. If the work done on the system is 10 joules, the amount of energy absorbed from the reservoir at low temperature is. So they want us to calculate the amount of energy being absorbed. So here the efficiency of the Carnot's engine is given by W by QH. Okay, so here W is the work done and this QH is the amount of heat added to system. Okay, so your QH will become W by efficiency, which is given by 100 joules. Okay, because W is 10 and efficiency is 1 by 10, so this will become 100 joules. Okay, now you have to find out the QC value, which is given by QC equal to QH minus W. So you have to know how much energy has been absorbed by the system. So it will become QH is how much? Here it is 100 minus the work done is 10 joules. So it will become 90 joules. So the amount of energy absorbed from the reservoir at low temperature is 90 joules. Okay, so now let us move on with the next question. Preeti reached the metro station and found that the escalator was not working. She walked up the stationary accelerator in time t1. On the other days, if she remains stationary on a moving accelerator, then the accelerator takes her up in time t2. The time taken by her to walk upon on the moving accelerator will be. That is, they have given you the two conditions here. First one is the accelerator is not working and she is walking on the escalator and the time taken for walking is time t1, whereas the second condition is the escalator is moving and she is not walking, she is stationary on the accelerator and the time takes for her is time t2. Now they want us to calculate the time when she is walking on a moving escalator. Okay, so first thing is you have to find out the velocity. So the velocity of the girl with respect to the elevator, we call it as VGE. This is the velocity of the girl with respect to the elevator, which is given by the displacement by time. Okay, next the velocity of elevator with respect to ground. So it is VEG. So this is the velocity of the elevator with respect to ground, which is given by T by 2, T2. Okay, so now we have to find out the velocity of the girl with respect to ground. So VGG is given by the summation of these two, VGE plus VEG. Okay, so here you know VGG is d by t, displacement by time. We have to find out this time only. Okay, and this is d by t1 plus t by t2. Okay, so if you solve this, you will be getting it as t is equal to t1 T2 by T1 plus T2. Okay, so the correct option is option number 4. T is equal to T1 T2 by T1 plus T2. Okay, so now we'll move on with the next question. A rigid ball of mass m strikes a rigid wall at 60 degrees and gets reflected without loss of speed as shown in the figure below. Okay, so they have given it like this. You'll be having a rigid wall and a ball is striking on the wall with a velocity v, and it gets reflected with the same velocity, and the angle between these two is 60 degrees. This is what they've given. The value of impulse imparted by the wall on the wall is, so they want us to calculate the impulse. So first what you have to find out is the initial momentum of the ball perpendicular to the wall. So initial momentum, you have to find out that, so which is pi, which is given by m into minus v cos theta. So here theta is 60 degree, so it will become minus v cos 60. So pi will become minus mv by 2. This is the initial momentum. Next what you have to find out is, you have to find out the final momentum. So final momentum is given by, this is the final momentum of the ball perpendicular to the wall. Okay, so pf is equal to m into v cos theta. So this will be mv by 2 again, because cos 60 is 1 by 2, you will be getting as mv by 2. So now you have to find out the impulse which is being imparted by the wall on the ball, so which is the given by the difference of final momentum and the initial momentum. So it's a difference of the final momentum and the initial momentum, so it will become mv by 2 minus mv by 2. Okay, so this will become plus, because initial momentum is minus mv by 2. So if you solve this, you will be getting it as mv. So the correct answer is option 1. The impulse imparted by the wall on the ball is mv. Okay, so now let us move on with the next question. In the spectrum of hydrogen, the ratio of the longest wavelength in the Lyman series to the longest wavelength in the Balmer series is. So they want us to find out the ratio of wavelength in the Lyman series to the longest wavelength in the Balmer series. That is the longest wavelength of the Lyman series and the longest wavelength of the Balmer series. So if you take this Lyman series and here this Balmer, what happens is for longest wavelength n will become 1 and n2 will become 2. Okay, this is for Lyman series, whereas for Balmer series n1 will become 2 and n2 will become 3. So if you know the general formula, E equal to hc by lambda. So here when lambda is increasing, automatically the energy will start decreasing. So 1 by lambda is equal to, okay, sorry, this is n1. So 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. So you will be getting it as 1 by lambda 1. This is for Lyman series. Okay, so you will be having it as r into 1 by n1 square is 1 and minus 1 by 4. So this will be 3r by 4. Similarly, for Balmer series, you will be having it as 1 by lambda 2 equal to r into, here n1 is 2, so it will become 1 by 4 minus 1 by 9. So if you solve this, you will be getting it as 5r by 36. Okay, so lambda 1 will be 4 by 3r and lambda 2 will be 36 by 5R. So the ratio of these two wavelengths only they have asked. So it will become 4 by 3R, 5R by 36. So R and R will get cancelled. This will get cancelled here. So the ratio will become lambda 1 by lambda 2 will become 5 by 27. So the correct option is option 1. So the ratio of the longest wavelength in the Lyman series to the longest wavelength in the Balmer series is given by 5 by 27. Okay. So we'll move on with the next question. A proton and an alpha particle both enter a region of uniform magnetic field B, moving at right angles to the field B. If the radius of circular orbits for both the particles is equal and the kinetic energy acquired by the proton is 1 mega electron volt, the energy acquired by the alpha particle is. So they want us to calculate the energy acquired by the alpha particle. So the kinetic energy acquired by a charged particle in a uniform magnetic field is given by q square b square r square by m. Okay, so you know q is the charge of the particle, okay, and m is the mass and r is the radius of the circular orbit. Okay, so here the kinetic energy acquired by the proton. So first kinetic energy acquired by the proton is given by q charge of a proton applied magnetic field and the radius divided by the mass of the proton. Okay, now the next one is the kinetic energy acquired by the alpha particle. So again the same equation, it will become q alpha square b square or alpha square divided by 2m alpha. Okay, so if you take the ratio of these two, the kinetic energy of the alpha particle and the kinetic energy of the proton, it will become q alpha by qp the whole square into r alpha by rp the whole square into mp by m alpha. So 2 and 2 will get cancelled. Okay, so here they given the radius is equal, so r alpha by rp is equal, so this factor will become 1. So you can remove that. And the next thing is you know the charge, that is the charge of an alpha particle is 2 times the charge of a proton. So q alpha is equal to 2 qp. So you can substitute in this. So this will become 2 qp by qp the whole square into 1. This is 1 because the radius is equal. And similarly the mass of an alpha particle is 4 times the proton. So m alpha is equal to 4 times of mp. So this will become again mp by 4 mp. So this will get cancelled. qp and qp will get cancelled. So you will be having it as 4 by 4, which is equal to 1. Okay, so the correct answer is the energy acquired by the alpha particle will be 1 mega electron volt. So the correct option is option number 1. Okay, now let us move on with the next question. Light of wavelength 500 nanometers is incident on a metal with work function 2.28 electron volt. The de Broglie wavelength of the emitted electron is, so they want us to find out the de Broglie wavelength of the emitted electron. So according to Einstein photoelectric equation, the maximum kinetic energy of emitted electron is given by K max is given by hc by lambda minus pi naught. Okay, so here if you see, lambda is the wavelength and pi naught is the work function. Okay, so they have given you the lambda value as 500 nanometers, or we can write it as 500 10 power minus 9 meters, and pi naught value they given it as 2.28 electron volt. So we have to just substitute in this formula. You know the value of H is 6.6 into 10 power minus 34, and C value is 3 into 10 power 8 divided by 500 into 10 power minus the work function is 2.28. So you'll be getting the final value as, if you solve this, you'll be getting it as 0.2 electron volt. So the K max value is 0.2 electron volt. Now we have to find out the de Broglie wavelength of the emitted electron. So the de Broglie wavelength is given by the formula lambda minima is equal to h by root of 2m K max. Okay, so here m is the mass of the electron, which is 9 into 10 power minus 31 kg. Okay, and you know the K max value is 0.2. So if you substitute in this formula, you'll be getting it as 6.6 into 10 power minus 34 divided by root of 2 into 10 power minus 31 into 0.2. So if you solve this, you will be getting the de Broglie wavelength as 2.8 into 10 power minus 9 meters. So the correct answer is option 4. The de Broglie wavelength of the emitted electron should be greater than or equivalent to 2.8 into 10 power minus 9 meters. Hope you would have liked this video. Thank you for watching this video, and prepare well for your examination. I wish you all good luck. Thank you.